Now let's look at question 10. The electric field strength is defined as the force per unit positive charge on a small test charge. So, small test charge. So the question is, why is it necessary for the test charge to be small? Okay? Now, the correct answer I'm just going to give you straight is A. So that the test charge does not distort the electric field. Right? Because let's say you have an area, let me just use this. Let's say you have a certain area, let's call A, and there's some there's an electric field in this area, right? And you want to measure the electric field at this point or this point or this point or whichever point, right? So what you do is you put a test charge there and you measure the force on this test charge, right? But if your test charge is very big, let's say 100 coulomb, it will distort the initial electric field which you are trying to measure. Okay? So therefore your test charge must be small so that it does not distort the electric field, because your test charge also will produce an electric field, and if these two electric fields overlap and the difference is very big, right? Therefore your new electric field will not be the same as your initial electric field, which the one you are trying to measure. Okay? So you have the electric field which you are trying to measure, I just call EM, plus the electric field of the test charge, right? And this will be your final electric field. So what you want to do is you want to make this very small so that EM is approximately EF, right? If you make E of your test charge ET approximately 0, right? Then if this is 0, naturally EM will be approximately EF. Okay? So that's what it's trying to say. So A is your answer. Let's look at B, and why. Knowing why A is correct, we still have to know why B, C, D is wrong. Okay? So that the force on the test charge will be small. Okay? This is not necessarily true, because what if EM, which is the initial electric field strength that you are trying to measure, EM is very big. Okay? No matter how small your test charge is, if you have a very large, okay, because remember, force is equals to E times Q. Sorry, let me just shift this. Force is equals to E times Q. If your E is very big, no matter how small your Q is, force will be very big. So this statement need not be true. If you have a large E field, which you are trying to measure, you have a small test charge, your force will still be very big. Okay? So B need not be true, even for a small test charge. Let's look at C. So that the test charge does not create forces on nearby charges. No matter how small your test charge, it will always create forces on nearby charges, right? Because it's a bit theoretical, but the electric field of the test charge extends to infinity. So any charges within the space of the test charge will experience a force. You cannot don't create a force on the nearby charges. Okay? So this is also wrong. And for D, so that Coulomb's law for point charges is obeyed. No matter if you have a small test charge or big test charge, Coulomb's law, I mean that's why I put a law, you know, law. Coulomb's law will always be obeyed, no matter what is your test charge. So this also doesn't make sense. So your answer must be A. Okay? Answer is A.